Okay, this is for making up the egg osmosis lab. Here are the directions for making up that lab. First of all, you want to print the lab sheet from the website where you found this video. Use the lab sheet as well as watching the video, and you're going to use that to complete all the questions, including the pre-lab questions on the beginning of the lab and the 10 post-lab questions at the back of the lab. And then when you're done with the lab, you're going to take that and you're going to turn it into chalk, either directly or into the work completed box. So real quick, in order to calculate the percent change in mass, we are going to use, let's see here, you need to take the, which number is it first? You want to take the final mass minus the initial divided by the initial times 100. Okay, so like for example, then, if I look on here for egg number 1, your initial mass was 81 grams or 81.4 grams, and after 10 minutes it was 81.7. Okay, if I want to find out the percent change at 10 minutes, I'm going to take the final, which was my 81.7. Whoops. I'm going to subtract the initial, which is 81.4. I'm working through one problem here. I'm going to divide by the initial mass again. So that was 81.4. And I'm going to multiply that by 100. Okay? So that's how I'd set up that problem. Okay? So what you need to do now is you need to take some time and calculate the percent change in mass for all of those. I can tell you this, that at 0, what's the percent change in mass? 0. Yep, but otherwise it should get bigger for egg 1, and it should be negative for egg 2. Why? Because in egg 2 your egg lost weight, so if you subtract a negative number, you're going to get a negative. Okay, so for eggs 2 and 4 you should get negative numbers for percent change, and for eggs 1 and 2 you should get 1 and 3 you should get positive numbers. Okay. Yep. Okay, once you have completed calculating your percent change in mass on your sheet, you want to find this graph that is part of your packet that you handed out. This is generated from our class data. And just a quick discussion of what do we got here. We have the eggs that were in syrup and what happened to their mass. And you find the 0 line here that tells you that these eggs lost weight. Okay. And then the egg that was in water gained mass. So remember, these eggs, the shells were taken off. Just the cell membrane was left. So that's semi-permeable. So we saw a gain in mass for the eggs in water, and we saw a loss in mass of the eggs in syrup. Okay, before you finish the questions, let's talk about why we saw what we saw with our lab. Okay, this is the setup here. We have 2 eggs without their shells, which means these are semi-permeable membranes. But you need to know a little bit about eggs. Eggs are basically where a living thing is growing inside the chick, and that living thing needs energy. And just like us, living things get energy in the form of sugar, and so there is sugar in the egg for that living thing to use. So we're going to just put some dots in here to represent sugar inside the egg. This egg would have a similar amount of sugar inside it. Now we took those eggs and we decalcified the shell, took the shell off, and we placed it in 2 different kinds of containers. We placed it in a container with just water. Okay, so if you think about that, in this situation, the concentration of sugar is highest inside the egg. Concentration is lowest outside the egg. There's no sugar in water. So just thinking on the lines of diffusion, then high concentration, low concentration, we'd expect the sugar to move out and we'd expect that egg then to lose weight. What we learned from this lab is that sugar cannot pass through the cell membrane. It's too big, but water, on the other hand, can. So kind of think of this the same way you'd think of your Kool-Aid. You have too much sugar on the inside, not enough sugar on the outside, you got to dilute it. And so water then, through the process of osmosis, will move into the egg, and that caused our egg and water to grow, to get larger. Water moved out of the cup and into the egg, diluting this sugar concentration. And because there's no sugar on the outside, it could never reach equilibrium, so it will continue to grow until it either causes the cell membrane to burst, or it reaches a tension gradient where it won't grow anymore because the pressure on the inside of the egg is keeping it from bringing water in. In this case, over here with the syrup, syrup obviously has lots of sugar in it, and so the concentration out here would be much greater. It's going to be harder for me to draw all these dots here, but there's going to be a lot more sugar outside of the egg than there is on the inside. So same kind of thing. If we were expecting just diffusion to happen here, we would expect the sugar to move into the egg and expecting the egg to gain mass. But sugar is too large, can't pass through the cell membrane, so water is going to try to dilute the sugar on the outside to bring these two concentrations to be equal. So water moved out of our egg in this situation through osmosis, again the movement of water through a selectively permeable membrane. And so we saw in our lab that this egg and syrup lost weight as a result of that, because water moved out to try to increase the concentration of sugar on the inside to match the concentration on the outside.